Well, after verifying that identity, of course, we could verify other identities, but let's get back to a couple of examples. We might still be asked to evaluate something, but we're not told, well, what angles add up to 13 pi over 12. Can we get an exact value of that? And the answer, of course, is that, yeah, if we know how to divide it up, we can actually get some values that might be useful to us. And I'll point out, one way of thinking about this pi over 12 business is to note that the angles that involve pi over 12 are sometimes sums of pi over 4 or pi over 3 or some sort of combination like that. Let's see, what do we have? We know that, for example, pi over 3 is equivalent to 4 pi over 12. We know that pi over 4 is equal to 3 pi over 12. Let's see, what else could we get right here? We know that pi over 6 would be 2 pi over 12. Now, none of these happen to add up to 13 pi over 12, but might note that in the second quadrant, pi over 4 is a reference angle for 3 pi over 4, and 3 pi over 4 does, when we multiply by 3 right here, become 9 pi over 12. And 9 pi over 12 plus 14 pi over 12 would add up to 13 pi over 12. Okay, so we can rewrite this, right? We can say, well, then this is the same thing as taking the tangent of 4 pi over 12 plus 9 pi over 12, or equivalently, the tangent of pi over 3 added to 3 pi over 4. All right. So how is that helpful to us? Well, in this case, we have a formula for a sum of difference of angles that involve tangent. And it goes like this. If we have the tangent of u plus v, it is the same as taking the tangent of u, in this case pi over 3, plus the tangent of v, and that's tangent of 3 pi over 4 in this case, divided by 1 minus the product of tangent of pi over 3 times the tangent of 3 pi over 4. Try and make that look more like a 4 right there. There it is. Okay. So let's make some substitutions right here. Tangent of pi over 3, we happen to know from our tables, is equal to radical 3. The tangent of 3 pi over 4, that is a second quadrant angle with a reference of pi over 4, and in the second quadrant, tangent is negative, and the tangent of pi over 4 is equal to 1, so this must be radical 3 minus 1 in the numerator. In the denominator, we're going to have 1 minus radical 3 times negative 1. So the number we're actually going to evaluate with is the square root of 3 minus 1 divided by 1 plus the square root of 3. Now this might be where you want to remember, how do we rationalize the denominator where we have a sum or difference of radicals? Well, the answer is to multiply by the conjugate of the denominator. What does that give us? Well, let's see. Square root of 3 minus 1 divided by the square root of 3 plus 1. I'm just going to change the order here. Times the square root of 3 minus 1 times the square root of 3 minus 1 is going to rationalize this denominator. In the numerator, we're going to get 3 minus 2 times root 3 plus 1. And in the denominator, we're going to get 3 square root of 3 times square root of 3 minus 1. Right? There is no middle term, right? Sum and difference binomials, the middle term would drop out. And so what do we have here? Well, it looks like we've got 4 minus 2 times the square root of 3 divided by 2. There's a common factor of 2 in the numerator, and so this is all going to reduce. This is going to become 2 minus 1 times the square root of 3. Well, there's our reduced answer right here. The tangent of 13 pi over 12 is 2 minus root 3.